Okay, so reviewing exponential equations to start. Reviewing. Here's an exponential equation. F of x equals b to the x. And the base is the b. When we do key points, they should always be -1, 0, and 1. Now, if I plug in those 3 key points to our base, no matter what b is, let's start with the middle one. What's b to the 0? B to the 0 is, everybody, more than one person? 1. Anything to the 0 power is 1. Let's do b to the first next. Everybody, b. Good. So then what is b to the -1? It's 1 over b. Okay? That is how it works for every single base. The asymptote, do we remember what the asymptote's going to be? Huh? Ari, what's the asymptote going to be? You're missing part of it. Something, yes. Y equals 0, thank you. So let's say we have the exponential function, f of x equals 5 to the x. So we'll start with -1, 0, 1, and we're going to put y equals 0 in the table as well. When we plug in -1, 0, 1, we use the key points 1 over 5, 1, and 5. Every single time. Do you notice how I did not write 0.2 for 1/5? Okay, I just reciprocated it. I'm not typing it in the calculator. So when we go graph it, we have an asymptote at y equals 0, which you can barely see because I'm putting black on black. We've got -1, 1/5, 0, 1, and 1, 5. And then the asymptote, the graph is getting closer and closer and closer to that asymptote. It does not cross through it. It's just getting closer to it. And that's our exponential graph. I'll review. And then down here, we have transformations, which we've already done as well. So this is all review. For the first one, if we have 5 to the x plus 3, 5 to the x plus 3, Sierra, can you tell me what that plus 3 does? Perfect. It translates up 3 units. And I can do this in a table, or I can just go to the graph and take each point and move it up exactly 3 units. But I have to remember, oops, I didn't move the first one up 3. I have to remember that something else is part of this graph that has to move up 3 units. So sometimes that's why I use the table, so I don't forget something. So if I actually use the graph, or the table, sorry, and I add 3, I'll have 3 and a 5th. I'll have 4, 9, 8, I mean. And then I also have to move my asymptote. So y equals 3 would be the asymptote when I add 3 to it. For 3 and a 5th, if we type that into Canvas, you're not going to write it as 3 and a 5th. You're going to either write it as a decimal, you're going to write it as a improper fraction, and improper fraction is what I prefer. And it's what's going to be most helpful for you when you go on to higher level math classes. So remember to write it as improper. We take the denominator, 5 times 3, and then we add 1. And that goes on top, so 16. And then the bottom number is the same denominator. So 16/5 would be what would actually go in this spot on canvas. Okay, h of x equals 5 to the x minus 2. Can you tell me that transformation? Translate down 2 units. Good. I'm not going to graph every single one of these. J of x, Brooke, J of x is 5 to the x plus 5. What's that going to do? Good. Translate 5 units left. Remember, we always do opposite for horizontal. Nina, can you tell me K of x? Translate 8 units right. Correct. All right, the next 2 of these has a negative sign, and they're in different places. Okay. The first one, Amar. The first one has a negative sign out front of the 5. Is that going to be vertical or horizontal? That is going to be vertical. So we are going to say reflect in the, now we got to figure out which axis vertical is. So imagine something that is reflecting vertically, up and down, it's reflecting. See my cute little heart? Which axis is that reflecting over? Tessa, which axis is this reflecting over? The x-axis. So if you know that this is a vertical reflection because of where the negative is located, and you're not sure if it's x or y-axis because this is the confusing one, just draw a picture. Or remember, we use our hand and do that. So the next one, Jacob, can you tell me what the next transformation is?
Horizontal reflection in the y-axis.
Good. It's horizontal because it's part of the exponent. So we're going to reflect in the y-axis. And then let's do the purple one. Let's do the m of x. I guess there's 2 purple ones. Let's do this one on the graph above, just so we've tried a second one. So we'll do reflect in the x-axis up here. Oh, shoot. Just kidding. Let's not do that one because then I have to erase stuff. Let's do the black one instead. I'll still make it purple up on the graph. Let's do this one instead. Okay. So we'll reflect in the y-axis up here. So the red one we've already done. I'm not using this anymore. I'm just using the original black points. And to reflect in the y-axis, we'll multiply the black points by -1. And I'll be graphing 1, 1/5, 0, 1, -1, 5. So when I graph these, where is my asymptote? When I graph the purple ones, I multiplied my x values by -1. Does that change a y asymptote if I multiply x's? Think about what I'm saying. Does not change anything in the y column when I multiply by x's. So my asymptote for this one is still at y equals 0. It just reflects it in the x or in the y-axis. Okay, so you're going to have some questions in your assignment today that are exponential, and some of our examples are exponential too. So we'll get those in a second. But that should be all review. The next thing review is how do we find an inverse function? So I'm going to use the exact same function that we started with above. And we're going to do f of x equals 5 to the x. That scared me. Emma, do you remember the first thing we need to do for finding an inverse function? Okay. Inverses have to do with x's and y's. And right now I don't see a y. Yes. Do you mean this x up here? Is that what you mean? Or do you mean this x here? A little bit louder, hon. Yes, except for not just that, but the entire f of x, that's going to be our y. Okay, so that would be my first step. Ella, do you remember what we do next for finding the inverse? Hey, ladies and gentlemen, we did this last week. It was on your test. Actually, we did in chapter 5 also. Ryan, do you remember? You switch the x and the y. That's how we find the inverse. We always switch the x and the y. Done. I found the inverse. Except then we solve it. We solve it for y also. So we switch x and y. And then we solve for y. That's what we do to find the inverse. We switch x and y and we solve for y. So I'm looking at x equals 5 to the y, and the y is in the exponent. Ashlyn, can you tell me how I get rid of this 5 so that it'll just be y? I'm going to log it. I'm going to log both sides. Log what base, Ashlyn? Base 5 of x equals log base 5 of 5 to the y. If I log both sides, the log base 5 of 5 to the y cancel, and we get y equals, and then on the other side I have log base 5 of x. So this is the inverse, and actually, since it's a function notation, we're just going to write it back in function notation. So this would be our inverse. Now, going back to the original question, we had ordered pairs for 5 to the x that were -1, 0, 1. And y equals 0. So -1 was 1 over 5, 1 was, or 0 was 1, and 1 was 5. Those are our key points that we had to memorize. When we were doing inverses in chapter 5, we were graphing inverses in chapter 5, and we would take these ordered pairs and do something to them. When we found inverses, we would take these ordered pairs and do something to them. Does anybody remember, before I just call on random people, does anybody remember when we were graphing? Tessa?
The x coordinates are now the y coordinates and the y are the x.
The x coordinates are now the y's and the y coordinates are now the x's. Perfect. We switched x and y. The exact same thing we did for the equation, we do to the ordered pairs. So now I have 1/5 -1, 1, 0, 5, 1. And then we have to switch the asymptote also. So instead of y equals 0, somebody want to guess? Because we didn't have asymptotes before when we did this. Does anybody want to guess instead of y equals 0? Come on, take a guess. X equals 0. Good guess. So we switched everything including the asymptote. So everything switched x and y. This is what we're doing today. That's new. We're just taking ordered pairs from the exponential and switching them. We can do that, right? We can switch x's and y's from a table. That's all we're doing new today. Okay? So let's go to the next page. That is logarithmic graphs. So a logarithm graph is the inverse of an exponential graph with the same base. So to find the inverse of the exponential, we use the key points, and switch the x and y values. So if we have f of x equals log base b of x, that's logarithmic, that has a base of b. So remember when we did this on the previous page, when we had b to the x, we did -1, 0, 1. And we had 1 over b, we had 1, and we had b. So now our logarithmic key points are going to be 1 over b -1, 1, 0, and b 1. Our asymptote is going to switch as well, x equals 0. And that's what we do for any base. So here we have an example of the inverse of the one we did on the first page. We've got log base 5 of x. So I'm going to make a table. And we already did this table on the previous page for 5 to the x. So I'm taking those numbers and I'm just switching the x and y from the previous page. So my -1, 0, 1 is going to be on this side. And I'm going to have x equals 0. So everything's backwards. At -1, I had 1 over 5. At 0, I had 1. And at 1, I had 5. So our asymptote this time is x equals 0. That is a vertical line. And you're not going to be able to see it very well because it's black on black. I'll just make it thicker. There you go. And I'll graph 1/5 -1, 1, 0, 5, 1. This is what a logarithm graph looks like. So let's talk about transformations with logarithm graphs. So once you have the key points, we can do transformations with a table. So the first one, Joel. Our first one is log base 5 of x plus 3. What does the plus 3 do? I can't hear you. What's the key word? Is it translate, reflect, stretch, shrink? Translate. So now the second part is where? Translate 3 units. So we need to know if this is vertical or horizontal. And sometimes it gets a little confusing because of the logarithm. Just compare it to the one underneath it. If you compare these two here, one of these is vertical and one of these is horizontal. To be horizontal, it has to be inside of the logarithm. Which one of those do you guys think is horizontal, top or bottom? The bottom one is horizontal. We can tell it's inside because it has parentheses. So this one's got to be vertical. So which way is it translating, Joel? Up. Yes. So when it's vertical, we just use the same sign. So +3 would make it go up. Let's graph that one. So in my table over here, on the vertical side, on the y side, I will add 3. And I'll graph 1/5, 2, 1, 3, and 5, 4. The asymptote does not change because the asymptote's on the x side, so the asymptote is still at x equals 0. And we just have the entire logarithm shift up 3 units. So how about the second one, log base 5, x minus 2. Evody? Translate, 2, yeah. I don't know what I heard. 2 units down. Excellent. Ketsia, the next one is log base 5 of x plus 5. Yes, very good. Translate 5 units left. Again, if it's the horizontal, we do opposite. Let's do that one on the graph. 5 units left. So for the table, for the table, I'm going to ignore the pink because I'm not doing that. But I'm going to do the 5 units on the left side, minus 5. So I'm going to take -5 and add it with 1/5. That's going to be -4 and 4/5, which I talked to you about earlier. We're not going to write as a mixed number if we type this in Canvas. So -4 and 4/5, I'm going to multiply 5 times 4 and add 4 to it. 5 times 4 is 20 plus 4 is 24 over the same denominator and keep the same sign negative. -24/5. Ooh. Then I'm going to subtract 5 and I'm going to subtract 5. And do I change the asymptote? If the asymptote is on the x side, can I subtract 5 from 0 and get a new number? Yes. So this will be y equals -5. Nope, not y equals. Sorry. Ignore that. So this will be x equals -5. So I'm going to take my asymptote and I'm going to move it. 5 units left. See, that's part of the graph, and I moved it 5 units left. Then I'm going to graph -4 and 4/5. -1, -4, 0, 0, 1. And we will have our logarithm just moved 5 units to the left. All right, let's finish up these transformations. Holland, can you tell me what f of x equals log base 5 x minus 8 does? Correct. Translate 8 units. Right. All right, and then we're to the reflections. We're to the reflections. We have to know which one is vertical and which one is horizontal. Sophie, can you tell me if when there's a negative in front of it, if you think it's vertical or horizontal? That is vertical. And vertical is a reflection in, reflect in the. So if I'm reflecting vertically, Sophie, if I'm reflecting vertically, try to reflect this, but I drew it really bad. If I reflect vertically, which axis is that? The x-axis, good. So that means this one over here, when the negative is with the x, that's the horizontal. And that's going to be reflect, oops, in the y-axis. Okay, so this is what we're doing today. We're going to graph a bunch of these. All right, we're going to have both logarithm and exponential. So we're going to start and we're going to look at f of x equals 3 to the x. You guys have to determine, is this logarithmic or exponential? Hint, does it say log? Okay, so then what is this? Exponential. Thank you, all of you who answered. It's exponential. What transformations are happening to 3 to the x on here? I will take your silence as the correct answer. There are none. So we are just going to make a table, and you guys, I don't have a ton of space for your table. So I'm going to zoom far in for the table. And we're always going to use for exponential -1, 0, 1, y equals 0. Our base is 3. So 1/3, 1, 3. So the equation of the asymptote, y equals 0. Ooh, is it growth or decay? That's from last section too. Is it growth or decay? Jackson, do you remember? Growth. This number 3, oops, is greater than 1, so it is growth. Let's graph it. Asymptote is y equals 0. All right, there's something on my screen. Okay, y equals 0, so we've got -1, 1/3, 0, 1, 1, 3. Domain. So we're thinking left to right. How far to the left? How far to the right? The asymptote stops the graph. Nothing else stops the graph. The asymptote is horizontal. Yeah, horizontal. So it's making the graph just go up, basically. So what stops the graph from going left to right? Nothing. So we say all real numbers. But the asymptote is stopping the graph from going all the way up and down. It's stopping it from going down. So what is the lowest number for that, for the range? Aya, what's the lowest number for the range? Nope, that's in the domain. Well, it is in the range. No, you're right. It's in the range. But even lower than that, what is this getting closer and closer and closer and closer to? 0. So 0 is the lowest, but it doesn't equal 0. So we write just greater than 0. It gets really, 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 really infinitely close to 0, but it does not equal. So just greater than. I'm pretty sure some of you on your test wrote greater than or equal to. These are just greater than. Okay, the next one. We've got g of x equals 1/2 to the x. Transformations, Ryan. Yeah. So horizontal anything is going to be up in the exponent. So there's nothing horizontally happening. The parent function is b to the x. So the parent function is 1/2 to the x. What transformations are happening?
Oh,
None. Yeah. Okay. So we're just going to make our table. And again, I didn't leave you a lot of space for this. You'll have more space, I think, on the assignment. Well, for some of them, you will. So I'm going to do -1, 0, 1, y equals 0. Oh, I never asked you guys. Is this exponential or logarithmic? Okay, because if it's exponential, we just use those key points. So for -1, we reciprocate and get 2. For 0, we get 1. For 1, we get 1/2. The equation of the asymptote is y equals 0. So y equals 0 is my asymptote. I've got -1, 2, 0, 1, 1/2. Well, I made a really good curve on that one. The asymptote is what stops either domain or range. The asymptote is horizontal, so it's stopping the graph from going down further. So what is the domain? What's left to right? Ashlyn, what's the domain? Yep, all real numbers. And then the range is up and down. Amar, what's the range?
y is greater than 0.
Good. All right, question 3. E to the x plus 2. E to the x plus 2. We need to know if this is exponential or logarithmic. Is this exponential or logarithmic? Sierra, do you know the answer? Does it say log? No, not logarithmic. So what is it? It's got to be exponential. See, we have e to the x. That's an exponent. The x is the exponent. So this is exponential. And I know why you were thinking logarithmic. That silly e in there. But just remember, guys, e is just about 2.7. So this equation kind of says 2.7 to the x plus 2. It's not 2.7. It's 2.7183 something something. But that's basically what this equation is saying. So transformations. Hanero, what does the plus 2 do to the graph? Where does it move the graph? If you need to look back up here on the first page, what does the plus 2 do? Oops. Oh, stay. Which way? Up, down, right, left. No, it does not do left. Left would be if the number was in the exponent. This number is not in the exponent. Which page am I on? Here it is. Not in the exponent. It's e to the x plus 2. So which of these is not in the exponent? Do you see my little thing moving around? Do you see it moving? This one is not in the exponent. So where are we going to move it? We're going to go up. Translate up 2 units. Okay, so I'm going to zoom really far in to make my table. Since this is exponential, I'm going to go -1, 0, 1, y equals 0. It's e. When we plug in 0, anything to the 0 power is 1. When I plug in 1, I get e, which is about 2.7. When I plug in -1, I get about 0.4. And those you were supposed to memorize last time we did the e's. So if you didn't get them memorized, we memorized those numbers. So you don't have to look them up. Now this does have a transformation on it, and it is going up. So that is to the y's. We're going to add 2. So we'll have 2.4, 3, 4.7. Do I change my asymptote? It's on the y side. Should I change it? Aya? Can I add 2 and 0 together? Yes. So my asymptote is y equals 2. So I'm going to go to my graph, and y equals 2 gets dashed in there for the asymptote. Oh, I didn't do, is this growth or decay? Emma, do you know if it's growth or decay? It is growth. The 2.7, the e value is greater than 1, so it's going to grow. I forgot to ask that question on this one too. The previous one that we just did, let's go back and answer that really fast. The 1/2 is not greater than 1. So Ella, what's this one going to be? That one will be decay because this number is between 0 and 1. Sorry about that. Forgot that guy. Okay, back here. -1, 2.4, 0, 3, 1, 4.7. Yes, Mar. Sure. About how I got to? Okay. So I'm just looking at my table. Well, I'm just looking at my table here, and this is all the y information. That's all the information that's y, okay? And then we had to add 2. Oops. So I wrote, my handwriting is really messy today, guys. Sorry. Move entire function up. So if I have y equals 0, that's part of the function. So that also has to add 2. That also has to go up 2. So for each of these, I'm going to add 2. Okay. Now, if I were doing a left transformation, not a left, a horizontal transformation, the green stuff, none of the green stuff would change. But since it's a vertical transformation, everything in green changes, and that's where my asymptote is. Okay. The asymptote for exponential is only on the y side. Okay. And that's when we do our domain and range. That's why our domains are everything, but our range gets stopped by the asymptote. So our range for this one, if I look at my picture, it's only above 2. So y is greater than 2. And that 2 is the asymptote. That's what the asymptote is doing. It's cutting off the range. Now we've got a few more examples with asymptotes, so hopefully you'll see a few more, or ask when you're doing your assignment. Okay, the next question is exponential or logarithmic? Logarithmic. How do you know that? I know it's a stupid question, right? Because it says log. That's how you know this is logarithmic. Okay, so I am going to make my table. By the way, there's no transformations for this one. I'm going to make my table with the inverse. So before I make my table, so this is for logarithmic. Before I make my table, I'm going to make a table with the inverse. So what is the inverse of this logarithm? So if I were going to ask you to tell me this logarithm, any information about this logarithm, it says log x. Can somebody tell me any information about this logarithm? What's special about this logarithm? Tessa, do you know?
It
Has a base of 10. Remember, if we don't write it, it's base 10. So the inverse of this logarithm is 10 to the x. Those are inverses, right? So I'm going to start by using 10 to the x to make points. I'm going to make it with the exponential points. So -1, 0, 1, y equals 0. So that'll be 1/10, 1, and 10. So before I find my logarithm, I make inverse points, 10 to the x. And where did I get 10 from? Sierra, do you know where I got the 10 from? Right, but what part of the log x did I get the 10 from? Well, how did I know it was 10? Because if it just says log x, that's automatically a base of 10. So I'm getting it from the base. All right, but that's not what I'm using for my table. I'm using the log x points, which means I switch the 10 to the x key points. I'm just going to switch them. So I have 1/10, -1, 1, 0, and 10, 1, and I will also have x equals 0. So I took my inverse points, 10 to the x, and I just switch. That's how I get my logarithm points. So there's no transformation. So my asymptote is x equals 0. And that one is vertical. Like everything's switched, x's and y's. I've got 1/10, -1, 1, 0, and then 10, 1. And then it has that logarithm shape. Our domain and range are also switched from the way they were in exponential. So for this one, because our equation of the asymptote is x, that's the thing that has a like smaller domain and range. It's the asymptote that affects it. Since it's x, that's going to affect our domain. If we look left to right, it does not go to the left. It starts at what number? From left to right, it starts at what number, Nina? What's my asymptote, Nina? 0. So this domain for this one is x is greater than 0. But the range goes up and down. There's nothing stopping the y values. So the range is going to be all real numbers. So that's totally switched from exponential as well. Everything's opposite. Everything's switched. So that's it for that one. Let's try 5. Jacob, number 5, is it exponential or logarithmic? Logarithmic. So if it's logarithmic, we have to find the inverse first. So the inverse is always the base. Jacob, what's the base?
1/3.
To the x. That's the inverse. I'm going to make points with 1/3 to the x. -1, 0, 1, y equals 0. 1/3 would be 3, 1, and then 1/3. Those are the inverse points. But it's logarithmic, so we have to switch them all. And I switched my asymptote. So there, I went and I switched my x and my y's, and I switched my asymptote. There are no transformations for this one because it's only the base and the logarithm. So there's no transformations. So that means my asymptote is x equals 0. I go to 3, -1, 1, 0, 1/3, 1. The domain is left to right, and because our equation of our asymptote is x, this domain is going to be x greater than 0. Then the range will be all real numbers. Okay, I'm looking for somebody to tell me why they think the pink and the blue ones are different. Both of those are logarithms. Both of them had no transformations. Why do they look like they're going different directions? Ashlyn. Ashlyn said one is growth and one is decay. When she said that, she's really talking about the inverse. The pink one, the inverse was growth. And then the blue one, the inverse was decay. So that's why it looks different, because growth and decay look different. Good job. All right. Log base 2 of negative parenthesis x plus 3. We got some transformations. So let's start with, is this logarithmic or exponential? Everybody. Logarithmic. Okay. That means I need to find the inverse so I can find the log points. The inverse of log base 2 is 2 to the x. It does not matter that there are transformations. We will take care of those later. We're still going to start with 2 to the x. I'm going to make a table of that. -1, 0, 1, y equals 0. That would be 1/2, 1, and 2. Then I'm going to go over here and I'm going to switch and do log base 2 of x. So we'll have 1/2, -1, 1, 0, 2, 1, and x equals 0. So I just switch, 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 switch. We do have transformations. Okay, Ariana, I'd like you to tell me what this negative sign does for the transformation. Okay, it's definitely reflection, but I want to check about where it reflects. Is this negative sign outside of the logarithm or inside the logarithm? It's inside. So it should be horizontal. So if I'm reflecting horizontally, which axis is that? That's the y-axis. Okay, so we got to reflect in the y-axis. And then, Warren, can you tell me what this plus 3 does? Translate left 3 units. Good. So we go to our table. And the first is reflect in the y-axis. That is a horizontal. And we also have translate left 3 units, which is also horizontal. So which thing do I have to do first? Multiplication or adding and subtracting? Multiplication, always before adding and subtracting. So we're going to multiply by -1. So I'll get -0.5, -1, -2. So I'm also going to take my asymptote and I'm going to multiply 0 by -1. What happens when I multiply 0 by -1? I still get 0, so my asymptote did not change, even though it is on the x side. It just didn't change because it's 0. Then we are going to left 3, subtract 3. So if I subtract 3 and subtract 1/2, that's, I'm putting it over here, -3 1/2, which is -7/2. Subtract 3, I get -4. Subtract 3, I get -5. Can I subtract 3 from 0, which is the asymptote? So I get x equals -3. So that is my asymptote, x equals -3. So I'm going to graph -3 1/2, -1, -4, 0, -5, 1. And graph my logarithm. Since our asymptote is x, the domain is affecting the x's. So our domain's going to be different. So we look at our graph. -3 is kind of that endpoint. Where is it graphed according to the -3? Holland, where is it graphed according to the -3? According to x equals -3, according to the asymptote, where is it graphed? To the left. So smaller numbers than -3. So I'm going to write x is less than -3. And then the range is going to be all real numbers. Again, the asymptote tells you which of the domain or range is being affected. Okay, I want to stop talking for a moment, and I want to see if you guys are understanding this. So I want you to start number 7 and see how far you can get. If you have any questions along the way, and then I'll go over it on the video. So this one is logarithmic. So that means we have to do the inverse first. And I'm not putting that inverse down by the table section because the inverse is not my table. It's how I find my table. And my inverse for this is going to be the base 4 to the x. So I do -1, 0, 1, y equals 0. So that'll be 1/4, 1, and 4. That is not what I'm using, though. For over here, we do log base 4 of x. So I have 1/4, -1, 1, 0, 4, 1, and x equals 0. Transformations, this negative sign in front is vertical. So we've got a reflect in the x-axis. And then the -5 is also vertical. There's no parenthesis, so that -5 is not inside the logarithm. It's after it. So translate down 4. If you already have this, down 5, sorry. If you already have this and you feel pretty good, you can work ahead to the next question. Okay, just letting you know you can do that. So I'm going to do my transformations. And both of them are vertical, so I have to do the multiplication first. So multiply by -1. And then that does not change my asymptote because my asymptote is on the x side. And then I'm going to subtract 5. That does not change my asymptote because my asymptote is on the x side. So my asymptote is still x equals 0. So I've got x equals 0. I've got 1/4 -4. 1 -5. And 4 -6. My domain is x is greater than 0. My range is all real numbers. So I'm going to work out the next one. If you got it, keep working ahead. The last one is ln. So I definitely want to do that together. But I'm just going to work out number 8, which is logarithmic. So I need the inverse of 2 to the x. Oops, I have something in my inverse wrong. If you're following me, I had to add 2 to my x's, which would change my asymptote to be x equals 2. For this one, my domain has to do with the asymptote, so the x's are going to be greater than 2, and then my range is going to be all real numbers. If you've already gotten number 8 done, I just want to ask you something that I think I threw on 2 questions on the assignment. How can we find x or y intercepts? Does anybody remember how to find either x or find y intercepts? It's always the same for everything you do in math. Every time. So I've been doing it since chapter 1. When you leave algebra 2, you should always know how to find intercepts. Who's got an idea? Somebody's got to talk. It's going to take forever. Ari. Plug in 0 for the one of those letters and you get the other one. So if I plug in 0, let's say for x, let's plug in 0 for x. So in my equation, I will have log base 2 of x, oops, that's x, sorry, 0 minus 2 minus 3. So I'm going to have log base 2 of negative 2 minus 3. Can you tell me where the x-intercepts are? I can't hear you, hon. Where would the x-intercepts be? That's not right. Hold on. Something's wrong. Oh, I'm finding the y-intercept. I'm sorry. This is the y-intercept, not the x-intercept. I knew something was wrong here. So the y-intercept, I plug in 0 for x. So I plugged in 0 for x. And where does it cross the y-axis? You can even look at the picture to answer my question. Where does it cross the y-axis? Warren, look at the picture. Where does it cross the y-axis? You're right, it does not. Also, what about this equation here means I can't find the answer? There's something here that you should immediately be like, you can't do that. Log what? Who's talking?
I'm saying, like, the log is there, so you can solve it.
The log is what, so I can't solve it?
The log is like in the equation, so you can solve it.
Oh, I can solve it. I can solve it. This is, by the way, y equals that. What?
Isn't the negative 2 after the log? You can't log.
We can't have log of 0 or a negative number. If we have that, it's undefined. We do not have an answer here. So there's no y-intercept. And that's because you can't have log of 0 or a negative number. So how about the x-intercept? Look at our picture. Looks like we're going to have one. So the x-intercept, we make y0. So I'll have 0 equals log base 2 of x minus 2 minus 3. So this is an equation we have to solve, which you did in the first section of logarithms. How do I get x by itself? Ryan, how do I get x by itself? Okay, that was correct. I add 3 to both sides first. Aya, what's the next thing I have to get rid of to get x by itself? What 2? No, not yet. That's going to be my last step. What's the next thing? I have to get rid of log. What gets rid of log? How? What do I cancel it with? What is the inverse of logarithms? Can't hear you. That's just of log base 2, but I mean of 10. Log base 10, the inverse would be 10, but this is not a 10. What in general is the inverse of logarithms? Anybody? Ashlyn? Exponentiate. Yes, exponentiate. So what base should I do to both sides? 2. So we're going to do 2 to the 3 equals 2 to the log base 2 of x minus 2. There's too many 2's. That's how I cancel out log base 2 is I do 2 to the. So now I have 2 to the 3 equals x minus 3. So how do we get x by itself? At 3. So I have 2 to the 3 plus 3. I have 8 plus 3. So what is my x-intercept? 8 plus 3 is 11, comma, x-intercept, comma, 0. So at 11, 0, my graph should be hitting the x-axis. Looks like my graph's a little bit. Why would it be 10? What's 2 to the 3rd? Oh, I couldn't read my handwriting. Thank you. Now I understand what you're saying. I have this number wrong. I mean, I had it wrong and then I made it right and then I forgot. This is 2 is what you're saying? Sorry. You are correct. My bad. Same work. Better handwriting. You could tell what's going on here. 10. So my graph should cross at 10, 0. Look, it's even more accurate now. There's only 2 questions that I adding the, I think only 2. Maybe there's more than 2. But make sure that we always know how to find our x and y intercepts. All right, last question. F of x equals ln x plus 4. Is this exponential or logarithmic? How many people think it's logarithmic? Raise your hand if you think it's logarithmic. Okay, how many people think exponential? Okay, we're gonna try that one more time. Raise your hand if you're a log person. This is a logarithmic. Raise your hand if you're an exponential person. What are you, Ella? Can't hear you. Exponential. What were you? Exponential. What were you, Ketsia? Okay, sisters are disagreeing. We're gonna fight it out. Ketsia, why do you think it's logarithmic? Because ln is the log base e. ln is natural log. So it doesn't say the word log. It is a log. Good job. And it was like half and half out there. So ln is logarithmic because it's log base e, natural log. So we are going to start with the inverse of e to the x. That's where I'm going to start this one. Inverse, e to the x. Negative 1, 0, 1, y equals 0. Memorize 0.4, 1, 2.7. It's logarithmic, so I'm going to take those points and switch them. And my asymptote becomes x equals 0. Transformations. This is a translate. Jackson, can you help me with this transformation? To the left. Yes, that is correct. We know it goes either right or left because it's inside the logarithm. It's got those parentheses. So on my table, I'm going to go to the x side and subtract 4. All right, so negative 4 and 0.4 is going to be negative 3.6. This is okay to put a decimal for this one because it started in decimal. Then we've got -3, and then 2.7 will be -1.3. X equals 0, that I can subtract 4 and get x equals -4. So that is my asymptote, x equals -4. -3.6, -1. -3, 0. -1.3, 1. Domain uses the asymptote because the asymptote is x. So our domain is going to be that x is to the right, or greater than -4, and our range will be all real numbers. Just looking at the graph, we're not going to find the answer. Is there an x-intercept? Looking at the graph. Yeah, it'll be what? Oh, actually, we can find that one. X-intercept is at -3, 0. Is there a y-intercept? Just looking at the graph. Does it cross the y-axis? Look at the graph. Yeah, somewhere here. This one I'm not finding right now because of time. But to find the y-intercept, you would make x 0. Actually, now I've already done this far. And to find the y-intercept, it would be at ln 4, which we could use our calculator for an approximation. ln 4 is the exact answer, but we could type it in to find the approximation on our calculator. All right,